Hey, Seraph here. Pertaining to this question, there's two methods. Basically, one is the long but proper method, and then the other one will be the short method to solve this. I will explain both. Let's start with the long method. For the long method, there's two key concepts you have to know. One is basically the octet structure. Octet structure basically means that something has to achieve 8 valence electrons in order to be considered as stable. That's the first principle. Second concept to understand is the amount of valence electrons equals to group. What does that mean is, if you look at a particular valence electrons, let's say electronic configuration of 2, 8, 3, this is considered as group 3. If it's something as 2, 8, 1, this is considered as group 1. It could be 2, 3, this is considered as group 3. With these two concepts, let's analyze the question. You have K, 3 lines, L, 1 line, M. Okay, so in this case, let's look at K in particular. 1, 2, 3. K have shared away 3 electrons. So in order for this to be stable, it has to be octet means 8. 8 minus 3, originally K has 5 valence electrons. That shows that this is a group 5. If you look at the selection, A fits the criteria of group 5, D fits the criteria of group 5. Continue to L. Look at L, how many electrons has been shared away? 1, 2, 3, 4. 8 minus 4 equals 4. L is considered as group 4. In other words, B and D ends with 4. That fits the criteria. Last but not least, look at M. M shared 1. So 8 minus 1 equals 7. This will be considered as a group 7. So C and D fits the criteria. By that case, answer will be D. That will be the long method to solve this. Short method requires us to understand the typical chemical bondings of ionic and covalent. Ionic requires metal and non-metal. When it comes to covalent, you will consider as non-metal and non-metal. So, because of this drawing on top, it shows that the electrons is sharing electron. And if it's sharing electron, it must be covalent. That also means that I could say any number, any last valence electron, so it's like 2.1, 2.2, 2.3, the last number of 1, 2, and 3, as long as 1, 2, or 3, they will consider metal. If there are 4, 5, 6, 7, 8, they will be considered as non-metal. By that logic, we just have to eliminate anything with a number, ending number that's 1, 2, or 3. So, because this is a 3, selection B is out. So, let's use different color. You use purple for this. Selection, because this is a 3, so this is out. This has a 2, this is out. So, by that logic, the only possible answer is D. And that will be the solution on how to solve this question. Thank you.